You are about to enter the courtroom of Judge Joleen. The people are real. The science is real. The evaluations are final. This is Judge Joleen.
Case number 100157, magnetic scientist virus. Are you conclusion lawyer?
Ms. Haley, will you come to the podium, please? Thank you, Mr. Seth. I will need your assistance further. Okay. You're reading the magnetic one, so I think it's on your right-hand side. Okay. Yep. Okay. So here's what's going to happen. Miss Haley here is the defendant. She has done an experiment and she has written a conclusion, and this science courtroom is about to judge her on whether that conclusion is valid or not valid. I will need a lawyer who is going to prosecute her based upon the conclusion that she shares with us. So think about anybody who would like to come in or come up here and be the prosecutor of Ms. Haley. So Ms. Haley, let's learn a little bit about your experiment. What did you do?
Okay, I performed an experiment determined on the larger magnets are stronger than small.
Okay, so hold on. Let me see if I can get this. Sounds pretty complicated. You took magnets that were different sizes.
Yep.
And you wanted to see if they had different strengths.
Yeah.
Like one was stronger than another one.
Mm-hmm.
You're talking some heavy science stuff here now, Miss Haley.
Okay.
Okay, continue on.
To measure the strength of each magnet, I held one magnet and determined how many smaller paper clips could hang from there before the last one falls. The hand of the judge, Exhibit A, which is the picture of your experiment at this time.
Okay, so right underneath that handout you have, there should be another one. Yep, and it says Exhibit A. Mr. Bailiff, Mr. Seth, would you get that Exhibit A and hand it to me? Thank you. And what's this a picture of, Miss Haley? Exhibit A is a picture of
The experiment of what I did.
So you didn't have the magnets fight it out to see who's stronger. How did you know about strength? What would you use as the measure of your strength on here?
The magnets.
Okay.
The
paper clips, right? If I could hold 6 paper clips versus 3, then you knew they were different strengths. Is that right?
Yeah.
Same magnets, right? Okay. Nice. I like it. Woo! We're talking some heavy-duty science you're doing here, Miss Haley. Okay, continue on.
Okay. I repeated measuring the paper clips 4 times.
Whoa. 4 times.
4 times.
4 times.
4 times.
You did the same thing 4 times.
Yeah.
Why, Haley? Why would you do that? Most common people do something once. One and done. How many of you heard that? One and done. Yes?
Yeah.
Okay.
Yes.
Why 4 times, Miss Haley?
Because I wanted to see if it would change at all.
Okay, so why would you think it would change?
I don't know.
Aren't you very good at doing this? You have to do it again and again. Some of your peers maybe help you. Why do scientists do a trial again and again, Miss Nikki?
Exact value.
It's exact value. We're going to get the exact value?
Yeah.
We're going to get the best value. We can't get the exact value, right?
Yeah.
So we get the next thing, the best thing, the closest thing to exact we can, and that's called, Miss Haley?
Best value.
Best value, right? So we know we are not going to, just like you said, we can't get it right the first time. We got to do it lots of time, and by the time we get it up done, doing all those times, we'll have a best value. Yes? So you're really smart. It's not stupid doing it 4 times. You're being really smart.
Yeah.
Yes. Of course you are, Miss Haley. Yes, continue on there.
Okay. For each magnet, it recorded all these trials are shown here on Exhibit B.
Oh, yeah. Exhibit B, here's her data. Because she did an excellent job. She did all of the trials. And then she has, look at there, it says best values right there. Nice job, Haley. Okay.
Also calculate the best values, which all average without any outliers for the trials.
Keep going.
Okay.
You were waiting for me to interrupt, weren't you?
Yeah. Okay. At this time, I will inform the judge what the independent variable of my experiment was.
Okay, well, Miss Haley, you said you got it. What is it?
Okay, so the independent variable would probably be the paper clips.
Okay, so you changed the paper clips because the independent variable is what you changed.
No, actually the magnets. I'm sorry, the magnets.
Okay.
Because I changed the size.
You did, exactly. That is exactly
The
what.
dependent variable.
Is which one?
The dependent variable will probably be the paper.
That's right. That's it. You got it. Okay, so we got an independent variable of the magnets. You changed the size. Dependent variable was how many paper clips that hung on them. Very good. Okay, so are we done?
No.
Oh, okay.
I will remind the judge that while performing this experiment, I first ensured that all magnets were made from the same material and that the paper clips were identical.
So when you do something that's the same and identical, what do you call that in science?
Oh, this big.
Very good. Yes, it is. You are all over the science stuff, Miss Haley. No wonder you're a defendant up there. Okay. Yes, that of course is your control variables.
Okay, finally, I wrote my conclusion. Okay. I believe that there is no relationship between the size of the magnet and its strength because in one of my trials, I found the middle-sized magnet held more paper clips than the other small size or large size magnet.
Okay, so I'm going to have you hold there because Seth and Hunter can't hear very well. So I'm going to repeat what you just said. This is her conclusion. This is after she looked at her data here. This is what she's going to say. This is it. I got the answer. I know whether the size of the magnet makes a magnet stronger or not. And you know what she just said? Nope. Nope, doesn't matter. You can have this gigantic magnet and you can have this small one and they could be the same strength. Doesn't matter. That's what she just said. And she based that on one of her trials. Because in one of her trials, she found the middle-sized magnet actually held more paper clips than the small or the large one. So she says, yep, that's it. Right there, based on that evidence. Am I right, Miss Haley? That's what you said.
Yep.
Yep. You got a couple more sentences? Okay.
Also, I believe that the strength of the magnet really does not have anything to do with the size, but instead depends on the material of the magnet is made out of. I rest my case too.
So you believe size has nothing to do with the strength of a magnet. It's about what that magnet's made of. That's what you believe? Okay. Thank you, Miss Haley. Don't know. This is a courtroom, not an audience. Okay. Have a seat. I need a prosecutor to prosecute Miss Kinley. I believe we discussed this yesterday. Would you please approach the podium there? And you will see, if you turn the page there, that you have already written out your prosecuting argument.
I have.
Yes, you have. Go for it.
Your Honor, I am here to accuse the defendant of writing an invalid conclusion.
Holy buckets and invalid. You're just going to step right up there and say, no way, baby.
Here is my evidence.
Oh, invalid. That's your stance.
Yep.
Let's hear it. I want to hear some evidence.
First, I will point out that the defendant, magnetic scientist, has used a lot of his opinion in her opinion and her experiments conclusion.
Whoa. This is a science courtroom. We don't do opinions in here. Miss Kinley, you're saying Miss Haley stood up there and gave me her opinion?
Yes.
Lay it on me.
This was stated in her last sentence, which states, I believe the strength of a magnet really doesn't have anything to do with size, but instead depends on what material the magnet is made out of. As you know, Judge, conclusions must stick to the evidence.
I do know that. Thank you for pointing that out. I do know that, Miss Kinley. Yes, we stick to the evidence. Does this look like a church room to you people here? I believe. This is not a church room. We don't believe here. We need evidence.
Second, I will point out that the defendant has also used only part of the data since she referred only to the first trial of her experiment while she completed 4 trials.
Excuse me, I'm getting very choked up here. Now you're telling me not only did she use her opinion, but she didn't even use all the data?
Now, yes, that's what I'm telling you.
Oh, I already have my verdict, but come on, lay it on me. What else? What else do you got?
As you well know, Judge Joleen, a valid conclusion requires a scientist to use all of the data. So Miss Magnetic Scientist failed to write about the best values of each of the magnets, which clearly show there is a relationship between the size of the magnet and its strength.
Clearly, it is right here. Miss Kinley, it's right here on this paper. Clearly, it shows that the small magnet only does about 2 paper clips. The medium magnet does 3.5, and the large does 4.5. That's the best values. It's clearly here, Miss Haley. But I think because Miss Haley believes that the size doesn't matter and it's all about the material, she just kind of ignored the rest of the data. Would you agree with me on that, Miss Kinley?
Yes, I would agree.
Finish up there. Do you have your ending statement there?
I do. Judge, we ask you to convict this dangerous scientist of writing a non-valid conclusion with the evidence we just presented to your most honorable court.
Yes, it is. Thank you for saying that. It is we do have a most honorable court here. So you want me to go to the highest level, non-valid.
Please.
Correct. Have a seat there, Miss Kinley. Let me consider this for not very long, because it's very obvious to me. Miss Haley, will you rise? Standing there, Miss Kinley. In the matter of case number 100157, with magnetic scientist versus the valid science lawyer, I find you guilty of a non-valid conclusion, Miss Haley. Your bailiff, I need you to escort the convict out of the room. Her punishment is 3 days of nothing but cafeteria